Hello class, my name is Matthew Medve and this is my 1.5 discussion presentation, How does sustainability apply to flight vehicle systems? Alright, we'll begin now. Alright, this slide serves as a reference summary for the creation of the system and subsystem matrix directed by this week's presentation discussion. Princeton University details that a typical system and subsystem structure for a conventional fixed-wing aircraft consists of an aerodynamic control surface system, an aircraft structural system, aircraft propulsion system, air data and flight instrumentation system, guidance, navigation, and control system, flight control computer system, and communication system. All right, so this slide displays the manufacturing life cycle phase of the major systems and subsystems that are commonly associated with a conventional fixed-wing aircraft with a corresponding sustainability element column of environmental, financial, and social performance. So up first, we have aerodynamic control surface systems. These systems generally consist of control surfaces like the elevator, ailerons, and the rudder, which all generate controlled movement of the aircraft. In regard to environmental performance relating to this subsystem, inputs include raw materials utilized during the manufacturing process, and outputs include factory emissions required to complete manufacturing. ISO 14001 Clause 6.1 applies to the input, and Clause 8.1 applies to the output. For financial performance, the manufacturer of the aerodynamic control surface system applies towards the input of sales revenue. The output for the financial sustainability element includes the cost of materials and energy required to complete manufacturing. ISO 14001 Clause 6.1.4 applies towards the input, and Clause 7.1 applies towards the output of this section. For social performance, this system's input requires skilled labor and talent management during the manufacturing process. The output results in the generation of jobs. The applicable ISO 14001 clause is 7.2. All right. Next up, we have aircraft structural systems. Elements of this system includes the wings, fuselage, horizontal and vertical tails, as well as additional structural subsystems for the attachment of engine and landing gear of the sort. Like our first system reviewed, the same inputs and outputs, applicable ISO standards for the environmental, financial, and social performance are the same. There would just be significant differences at lower levels, like the type of raw materials used during manufacturing, sales revenue, figures, cost of materials used, and the type of labor skill required. All right, next up is aircraft propulsion systems. This system consists of the aircraft engines, associated fuel tanks, and related hardware. As with the other two systems reviewed, the same inputs, outputs, and applicable ISO standards for the environmental, financial, and social performance are the same, with the same significant differences at lower levels mentioned previously. All right, next we have air data and flight instrumentation systems. This system consists of many instruments and devices that enable flight crew to have the ability to monitor and measure flight properties and performance. Examples, include altimeters, airspeed indicators, engine gauges, tachometers, and artificial horizon. As with the other three system reviews, the same inputs, outputs, and applicable ISO standards for environmental, financial, and social performance are the same, with the same significant differences at lower levels that we discussed previously. All right, next we have guidance, navigation, and control systems. These systems include avionics that are used for guidance, navigation, and control functions. Examples include distance measuring equipment, magnetic compasses, gyroscopes, inertial navigation subsystems, GPS, and instrument landing subsystems. As with the other four systems, same inputs, outputs, and ISO standards for environmental, financial, and social performance, with the same differences at lower levels that we also mentioned. All right, next we have flight control computer systems. Flight control computer systems are comprised of embedded computer subsystems that are part of an integrated avionics package that performs guidance, navigation, and control functions. Examples include flight control computers that often carry out computations associated with routing of the aircraft, autopilot, and as well as providing the interface for avionics that's responsible for flight data displays in the flight deck for the cockpit. As with the other systems, same inputs, outputs, and ISO standards for each area, and the differences at the lower levels that we mentioned previously. All right, so lastly for this section, we have communication systems. Examples include transponders that provide positive identification of the aircraft to air traffic control, VHF voice radios, and omnidirectional radios. As with the other, reviewed, same deal, same inputs, outputs, and ISO standards for environmental, financial, and social performance, and differences at lower levels that we mentioned previously. All right, so this slide displays the operations lifecycle phase of major systems and subsystems that are commonly associated with a conventional fixed-wing aircraft with the corresponding sustainability element column of environmental, financial, and social performance. Since we already reviewed what elements make up each of these systems, we'll focus on the difference in each sustainability element column as well as the ISO 14001 clauses. So, for aerodynamic control surfaces, systems for environmental performance, the input would be hydraulic fluid and maintenance to support operations. Output would be corresponding energy and emissions required to support maintenance operations. Applicable ISO 14001 clause, as you can see, is 6.2 and 8.1, which are the same for all other systems displayed on this chart. For financial performance for all systems displayed on this, input would be sales revenue supported by airline tickets and transportation of goods. Output for all systems in this chart for this section would be maintenance and operating costs. For financial performance, all inputs and outputs for all system sections are the same, as is applicable ISO 14001 clause for this section being 6.1.4 and 7.1 respectively. For social performance, it's the same as the previous phase, as skilled labor and talent management is required to support all of these systems. The input and output for all of these systems are the same, with the significant differences being lower level details in areas of expertise for each system. ISO 14001 clause 7.2 applies to all systems for the social performance section as well. Now to focus on the environmental performance column for each section. For aircraft structural systems, electric power would be input and output would be emissions generated due to electrical power to support the system. And like similar structure mentioned previously, these inputs and outputs are the same for guidance, navigation, and control systems, flight control, computer systems, communication systems as well. For aircraft propulsion systems, however, aviation fuel would be the input and the resulting output is corresponding emissions generated. All right, so this slide displays the decommissioning life cycle phase of the major systems and subsystems that are commonly associated with conventional fixed-wing aircraft with the corresponding sustainability elements like previous. It might be a little shorter to summarize. For all systems for the environmental performance section of the decommissioning phase, input is the scrap and recycling of system components, and output is associated scrap, recycling, and hazardous waste emissions. Difference in scrap and recycling methods would obviously differ between systems depending on the components to be recycled or scrapped. ISO 14001 clause for this is 6.1, 6.2, and 8.1 for all systems for the environmental performance section. For all systems for the financial performance section of the decommissioning phase, input is the scrap and recycling costs of decommissioning system components, and output would be revenue generated from selling scrap and recycled materials if you can. ISO 14001 clause 6.1.4 and 7.1 for all systems for the financial performance section are applicable. The social performance section of each system input, output, and ISO clause is the same as the previous two phases, as skilled labor is required for decommissioning, which generates jobs. ISO 14001 clause 7.2 applies here as well. But here is the reference I used for this presentation. That wraps up my presentation. You all have a great weekend.